16th inch material, your notch is going to be a 16th of an inch, 0.062, and that'd be about that deep too. So I want you to show your flat patterns and show those bend reliefs. It's a good exercise to go through the flat pattern too, just to make sure you actually can fold it out of a single sheet and you're not doing something that just actually can't be accomplished. Okay, so that's bending. A little bit more on punching. So when we have our sheet and you're punching a hole, you can't punch a hole too close to the edge like this, because if you do, it's going to distort the material. It's going to flare out like this. So the rule of thumb again is the space between the hole and the edge should be equal to the material thickness. So T, right? At least the material thickness away from the edge. Same thing if you have two holes next to each other. They also should have T in between them. Because again, those holes are just going to get distorted. You punch the first one, then you punch the second one, it's going to end up distorting the first hole. If you don't allow at least the material thickness in between. And then the same thing is true on your bends. So if you have a bend like this, all bends are round, by the way, like this, and I'll talk about that in just a moment. They're not totally square. You want to keep your hole at least the material thickness away from where the bend starts. So T as a minimum. If you put a hole too close to this edge, it's going to end up getting distorted. It'll get wrapped over this edge like this and look really goofy. Yes.
Is it similar to the acrylic where it has to be 2 times the material thickness?
Yeah, you're jumping ahead.
Alright.
Then the bending page. Yeah. So this is a very important rule, and it's the same as the acrylic. And your minimum bend radius is 2 times T. Definitely want you to specify that on your chairs. And when you render them or sketch them, they should look like they not have sharp corners, definitely. Now that 2 times T is going to vary with the material. Aluminum is a little different than cold rolled steel, which is a little bit different than stainless. But that's not so important that you guys learn all the ins and outs of each one of those, as long as you understand the concept that you need roughly 2 times T or even more is a good idea. So there's not a lot more to know about doing chair number 1. Fairly simple process. Start with a big sheet, you punch holes in it, you punch the outer perimeter of the shape, you punch some bend reliefs, and then it moves from there over to the break forming machine, and it's bent into its shape, and then it's riveted together, and then it's plated or allodyne or painted or whatever kind of finishing you want to have on it. Yes?
What would you say would be the biggest and the smallest sizes of the plastic for punching?
Oh, yeah. They definitely have punches that are down to like really small, like say a 32nd of an inch. But you can only use 30, I didn't talk about that rule yet. You can only use 32nd inch die on 32nd inch material, right? You can't go through 1/4 inch thick material with this thin little piece of metal. Anyway, and then like in a round or square, they probably go up to, most shops will probably have something 1.5 inches. Something like an inch maybe, I don't know. And that will vary with the material that you're using again, because it's really hard to go through really thick steel and stuff, so you have to use bigger dies. But yeah, that's kind of a general rule of thumb. They'll have squares, rectangles, circles, maybe some oblongs, things like that.
Are you gonna talk about it all? How they do the like,
Oh yeah. So it's called, yeah, those louvers. Those are called half shears, and it's very very similar to the same process, except that or it happens on the turret punch. Sorry. It actually happens here, where the die is designed such that it cuts through one side, but not the other. It just kind of pushes the material down in. There's a few half shears, I think, on that sample that's going around too. And you're welcome to put those on your design if you like.
are they just like angles?
Yeah, but it's kind of hard to explain. There's these other little ones too that are kind of half sheared, so that this is sort of a half shear, right? So the die doesn't have metal over on that side, so it just pushes it down in. It's a soft surface as opposed to cutting through these two. These little details here, maybe I'll let you do that too. This is called coining, and that's where you are distorting the material a little bit. So they'll use a tool. Actually, it happens on the turret punch, and the tool is like I call it a hot dog. So it's sort of a hot dog shape like this. And when you punch the material, it ends up giving it the detail like that. So on the flat sheet, the detail again is sort of an indented hot dog shape. And that gives you more structure again, because we're moving material away from the neutral axis.
That's called coining.
Yeah, coining, like the coin that you might have in your pocket. There's also another technique for doing this where they use a wheel so they can make a longer one, but let's just assume that we're going to do kind of short little ones, and they can be round point. They don't have to be hot dog shaped. You can be coining little bumps like that and stuff too. Yes. Question?
I was just going to ask if we can use a bead roller.
Yes, that's the one I was just talking about, right? So you can do a longer one. Yeah, let's go ahead and do that. He just mentioned something called a bead roller. Is that the term? I know they're called rollers, but yeah, so you can use a bead roller too to do the same kind of thing. So you can do a kind of like that hot dog detail I did, but make it longer. That's fine. But if you're going to do a technique like that, you need to draw a picture of the equipment that does it.
Yeah, that means it has to be a certain size. I can't use it for a whole seat. Right.
You do them successive lines, right?
Oh yeah. Yeah. So I guess you could then just.
And there's a little bit of handwork involved, so it's not quite as automated as some of this other stuff that we're looking at here. Okay. Let's see. Got a little bit of time. Okay, so now the fun part. We'll talk about. Not that this one can't be fun. You can do some cool looking chairs this way too, but chair number 2. So here, we still start with the sheet, but now we're using a laser to cut. So now, you can do whatever shape you like. And you can put whatever shape holes you like. So, I'm not saying make it ugly like I just did, but when somebody gives you the opportunity to do whatever shape you want in the world, I don't expect you to come in with rectilinear shapes. Okay. I'll talk about, I don't know if I'll have time today, but talk about the difference between lasers and turrets, but one of the big advantages, of course, is that you can get a nice smooth cut, right? There's no nibbling. It just It just cuts nice and smooth. Actually, maybe I will do that right now. Laser versus turret. By the way, the turret punch is really fast and loud. No metal around here I can bang on. Oh yeah, there we go. So, yeah, it's kind of like that. That's how fast it does it punches a hole. Each one of those was a hole being punched. It's a pretty fast process. And they let the machine run all night long. There's a sheet loader. They just load up a bunch of sheets on the sheet loader, and then they turn on the machine and go home, and then come back in the morning with a bunch of punch sheets ready to go. They do a lot of the programming and stuff like that in the daytime. Okay, so the turret is fast. We think of lasers as being fast, but the laser is slow by comparison. The turret is also accurate. It's more accurate than the laser. These holes are it's very precise. When you specify the size of a square hole, it's going to be like dead on laser. Because it's melting the material, you're going to get a little bit of variability that's harder to control. So the turret's more accurate. That's not usually a big criteria for choosing the turret. The speed is the big one, which means it's lower cost. The one thing that lasers got going for it is you can do thick or thin. So if you wanted to cut something that's like, say, aluminum foil, and you put that on a turret punch, it's going to just crunch up into a mess when the die tries to cut through it. Where with a laser, no problem. You can get a nice clean cut on aluminum foil. And you can even stack up 5 layers of aluminum foil and cut that on the laser, so you get 5 pieces at the same time. You can also cut through some very thick material. On a laser, you can go through 1/4-inch steel, if you have the right laser. 1/2-inch steel, even more so. With the turret, there's a limit to what those dies can do. So you can do very thick things, do very thin things. Obviously, the laser allows you to do contours. So and curves, Again, on the turret, you'd have to nibble, and then you'd end up with the burrs and stuff like that, so it's kind of a pain. You can also go just partway through the material. You can etch. With a laser, you can etch graphics and things like that. And one of the things that is nice about a turret, though, again, we think lasers as being really precise, but I think we've talked about this a little bit before, is that you get a straight cut. So when you go through the material, the edge of the turret part is going to be like that, and the laser is going to have an angle to it. I've exaggerated it for the sake of seeing what's going on here, but it's not going to be perfectly straight going through the material. So turrets are used whenever possible. If you don't need the laser, don't use it, because it's just going to add cost. But if you have a curvy shape, you're kind of limited to that. Now, Tobar actually has a fairly new piece of equipment. It's a combination turret laser, so they can put the job on there, and they just laser the parts that need to be lasered and the parts that can be turret punch or punch, and so it's really quite efficient. Nice for us industrial designers. Interrupt me anytime there's a question. Okay, so here's your, now I have to try to draw the curvy chair. Let's see, what do I want to do? Okay. Oh God, I gotta erase that. Oh, he's recording it too. Now there's proof that I drew really poorly there. I was running out of space. Let's see. Okay, so I've got a couple of, two parts. I want you to have at least two pieces that you, or two parts I'll call them, that you join together using fasteners. Remember the kind of fasteners with machine screws. So the first part is the seat here, and what that is, I'll turn it upside down so you can see the inside of it. It looks like this. So this is a couple of laser cut parts, a couple of half moons, and then this middle piece here that gets rolled. And so you've got a series of 3 rollers like this. And you put your piece in there and roll it into a curved shape. What's this? And then these 2 end pieces are simply flat parts in this case. They can also be curved, but